Hey, welcome to the shop. We are continuing with part 2 on the alignment series, part 1 being the pre-inspection. Now during the pre-inspection, you want to make sure that after you've inspected everything, that you brought the inspection back up to spec. So the truck is back up to spec according to the owner's manual. From there, we're going to continue into this part of the series where we will be dealing with the measurements and the alignment. Well, one thing you need to decide when you're doing the alignment is what kind of alignment are you going to do. There are several different kinds, several different methods. The two that I know of, one is geometric center line, where you are doing an alignment based off of tire position and axle position. This alignment is used basically because the frame has been in an accident and there is severe damage to the frame. Or you may be unsure of the frame's condition. Now then there's frame center alignment, which is going to be the method that we're going to be using, where the frame hasn't been in an accident, you have access to the frame, and the tools that you'll be using will square all the axles to the frame and bring those wheels within that alignment spec. So first you want to start out with basically your coasting stop. The reason for the coasting stop, as I explained before, was so that the truck is not altered. So it gets into that natural rolling state, the way it would be if it was driving down the highway. If you slam on the brakes and you cause the truck to lurch or jolt, you're putting everything out of alignment. You're putting pressure on the suspension, and everything will be tilted or leaning, so you won't get accurate measurements. So you want to go to a flat level surface and you want to coast to a stop with as little braking as possible. Then what we're going to do is we're going to bring up this sheet right here, and from here I'm going to show you where we start our measurements. So I'm going to use a more open truck than the 98 Pete that I was showing in my first video, and I'm going to show you a different vehicle, a different truck. That way you can better see how to do the alignment based on the measurements. Alright, so let's get started. We're going to start with the first measurement, but before that, I'm going to go ahead and talk to you a little bit. So with your measurements, overall, all the measurements you're doing on the truck, you are basically going to either create or find fixed points on the vehicle in order to do your measurements. So some of the points you'll be able to measure because they are immovable, and other points you may have to create because you have nothing to fix to. So this current measurement that I'm going to do, we're going to start on the first drive line. This is going to be the thrust measurement. I'm creating a fixed point because I am taking a square piece of stock, as you see here, laying across the frame. I've C-clamped it down and I've squared it. And so now that I have done that, I've also measured the tire from the flat surface to the top of the tire. I've found the halfway point and I've marked it on the tire. You'll see just that right at the tip of my fingertips there, the little white chalk mark. And I'm going to measure from the stock to the chalk mark. I'm going to do this on both sides. I'm going to compare the numbers, and that's going to give me my thrust reading. So that'll be the thrust, the forward or backward of each side of that. And then we also will go through, we'll take the offset reading, so we'll get the measurements for offset. Once we've squared that, all our other readings we can base off this axle, so we can move and do the rear end, do the tandem. So we can take the tram measurement off that and then make your tram and offset and adjust that rear axle. Then you'll have both axles adjusted. Then you can go on and move to the steering, and you can do the setback, which will give you the thrust for the steering, and go on from there. So as I said, every measurement you do, you are either finding or creating a fixed point and taking that measurement. And then once you've gotten those measurements and compared the numbers, that's where you're going to find your specs. That's where you're going to find the numbers to compare it to the manufacturer's spec to make that adjustment to. And then when we're all done, we'll talk about when you've gotten those numbers and you have to make your adjustments. What do you do to make your adjustments and where? So let's get started. We're going to go ahead and we're going to use this age-old, time-tested tool. This is for basically out in the field so that even drivers can do it. Tape measure, square piece of stock. If you don't have the stock, there's a string method where you can take the string across the tire and measure it in comparison to the front steer, and then get your thrust reading that way and see what the difference is. All right, so I'm going to go ahead and get this measurements, as I said, on both sides. Okay, so here we're going to be measuring offset. Now offset is going to be a measurement that's going from the frame to the tire, and you're going to measure the offset on both sides. So you'll get this number, and the difference in the numbers will tell you which way the axle is in opposed to the frame. So we're going to measure this from the frame to the tire, and then we'll take that number and add that to our alignment. So here we are back at the drive tires. Once you have your front drive squared away, then you want to square the rear drive to it. So one of the measurements you're going to take to help square that is going to be the tram. Now the tram, there's a trammel bar that measures from the center point of the fixed axle to the center point of the other axle, and you take that reading on both sides, and the difference will tell you if the rear axle thrust is off. Another rudimentary way to do it: tape measure 2 fixed points. Closest points I can get a good reading, edge of the rim to the edge of the rim. And if I do that right at the center, that'll give me a good thrust reading. I'll take that reading on both sides. That'll give me my numbers to tell me if I have a thrust problem on my rear tire or my rear axle. Okay, now for this measurement, we're going to be measuring toe. So we're going to measure toe in and toe out. We want the toe to be in slightly so that as we drive, it'll push the toe out and bring it close to zero. Now in order to measure toe, there's several different ways. One, you can scribe the tire and measure from the points, again creating 2 fixed points to measure from. This way, this method I like. You take 2 bars and you hang them on either side of the tire at about the same height, same level, and then you run a tape measure from one to the other, and you'll measure the front part of the tire and the back part of the tire. Then you take your numbers and compare them. Now we've already done this earlier, and I'm going to demonstrate it shortly and then show you again. Our number, we ended up getting about an eighth inch of toe in. So that's a perfect amount. So as it's driving, it'll push out that 1/8 inch, bring it to zero, and give you that perfect rolling. Alright, here we are again. We are on the passenger side of the truck, so I can give you a clear viewing of this particular measurement. On this measurement, we are measuring caster. Now caster is the forward or backward tilt of the axle. So we're going to start where we're going to utilize the tool of a protractor. Now there are several different types of protractors, analog or digital. At this school we have a digital protractor. And what you'll do is you'll turn it on. Alright, then you will set it to the frame, and you will zero out on the frame because this measurement is taken from the frame. So we will hold the 0. There we go. Protractor is zeroed out. Now what we're going to do is we're going to bring it down here to the spring seat. And from here, we're going to take our reading. Now this reading is done on both sides of the axle. So here we are getting some wobble. Here we go. We are getting a 3.5 to about 3.6 on the protractor. And remember, this measurement is taken on both sides, so that'll show you if there is a twist or skew of your axle, and that'll let you know, whether or not that needs to be repaired, or if that caster is set right. So you'll measure that and make sure that it's within spec for the caster. Now, every truck, based on its steering, manual steering or power steering, will have a different caster. The more extreme the caster, usually with power steering, because you need that power steering to help you ride that vehicle. Some casters getting to be about near zero, but some caster helps because it helps with that natural steer. And here I'll show you really quick, basically an example of caster and what that is on an extreme measure, and you've seen it every day. All right, so as I've said, here's our example of caster. Now here's an extreme example of caster. This is exactly how it is on a steer tire, of course, but you have the same principles. You have the pivot point, and you have a thrust angle. So as this caster will move forward, the natural drag that happens is it's going to pull that caster into a naturally rolling position. So there you go, natural roll. Now if this caster were to have a change in thrust, it'll change and where the caster goes. So you see this in steer tires as you get where the caster is set, where it's a positive caster, that the axle has a rear tilt, a rearward tilt, to help create that caster, and that caster will be greater or less depending on if you have power steering or whatnot. Now there's also other things to take into consideration, like kingpin inclination and whatnot. This all will affect the caster and also how the power steering will operate on that. But that movement of force will cause the wheel to be straight and go in the direction of the force. That's what happens with your steer tires. So you want to check that. You want to make sure you have the proper caster so that you get that natural pull. Now we'll go on to the next measurement. So now we're going to show you a different measurement. This measurement is not quite used for doing your alignment. This measurement is a measurement that you can take. It's not something you can adjust. It's only something you can fix if it is off. But this measurement is camber. Camber is the lean in or lean out of your tire. So if you're looking at the sign, or at the side. So positive camber, the top of your tires are leaning out. Negative camber, the tires are leaning in. So we are checking that camber, and the reason why is because on a truck, again, some manufacturers, because of the strength of axles has increased, camber is being brought to near zero, so near perfect. But on older models, you're going to see basically a positive camber, and this is considered a preload, so that when the truck is loaded, the weight of the axle will bend and it'll bring that tire in straight, and you'll get that straight roll down the road. Now, one of the signs to look for without using a protractor is tire wear. You can have tire wear on the inside or the outside, which could be from camber. So if you have it only on the one side, you may have a camber issue. So on the inside of the tire, you're going to have a negative camber. On the outside of the tire, you're going to have positive camber. And so we'll go ahead and show the measurement. Now the measurement, again, done with a protractor. This is a digital protractor that we use at the school. And what you'll do is you'll come down here and you'll take the protractor, turn it on. Again, you will zero it out. You want a relatively flat surface. And once it's zeroed out, you'll take the protractor and you'll bring it up to your rim. Now, when you're bringing it up to your rim, you want to be sure that you're putting it on a flat spot on your rim. Some of these aluminum rims can get nicks, dents, warpage, and cracks. So you want a relatively clean, flat surface when you take your measurement. So when you measure it now, the protractor thinks that the upright is basically a zero plane, and it's reading from a zero plane. So we'll have to take our, what is it, 89.8, and basically find the difference between 89.8 and 90 degrees. Alright, and that will be your camber measurement. Now remember, camber measurement can only be fixed. It cannot be adjusted. The only way to fix it would be to replace your hubs, check your hubs, or the kingpin, and replace the bearings on your kingpin. So in this measurement, we're here at the passenger side steer axle, and this is the front of the axle, and this is forward. So here we have the spring hanger. This measurement's going to be from the axle to the spring hanger. You want to measure the same points on both sides so that your numbers can be accurate. This measurement is going to give you the thrust angle of the steer axle, which is going to be sort of relative to everything else, but that will give you this. So we will go from a fixed point, which will be this U-bolt, to the bolt on the spring hanger, and I want to measure at the same point, and then take that same measurement on the other side. Okay, so you've done all your measurements. You've checked your steers, you've checked your drives, and now it's time to set everything into place. Well, when you do your drive, you want to start with that first drive. Everyone goes, well, now what? I got the measurement. Well, now it's time to make your adjustments. So at this point, this is where you begin adding or subtracting shims. Shims are pretty much the way you make all the adjustments for your drive and your steer axle. Your steer axle will take tapered shims where it's thin on one side and fat on the other, and you will drive those shims in. That will give you your caster for your alignment. If the thrust is off, then you'll loosen U-bolts, and there'll be a little slop, a little play in there, and you'll make your adjustments that way, and then retighten those down and torque to spec. For the drives, it'll be on the leaf springs. There will be, or for your air ride system, you'll find points at where you can shim it to correct the thrust angles on that, as well as your rods across the top. You'll shim that to correct the centering to your frame. So basically, shim is just for those is just a piece of metal, almost like a washer, sometimes open-ended, so that you can slot it down in and then tighten it. And you put enough of those, and it creates a space and a shift. You are dealing with angles when you are dealing with your thrust, so you're going to have, a 1/16 inch shim is going to give you like a large, like almost like quarter inch shift or play. So you're doing that angle. So here, you're doing a small little shim, but it's going to affect your angle greatly depending on how much you give it. So you take that into consideration, except for when you're dealing with your offset. When you're dealing with offset on the drives, if it's centered, a 1/16 is going to be a 1/16, so you're going to have to adjust your offset that way. So you basically compare all your numbers to manufacturer specs, get the appropriate shims, and put those shims in place. And once you've done that and you've rechecked and redo all your measurements, because you want to double check that you got it right, redo all your measurements, and you should be good. And everything should be within spec, and there you have a full alignment.